Now let's do another example with energy. Here we have a sledgehammer with mass of 6 kilograms that is moving down at a speed of 7.6 meters per second when it strikes a fence post, driving it 14 centimeters further into the ground. And question A, part A, asks us, what is the kinetic energy of the sledgehammer? So for the kinetic energy, we have this formula. EK is equal to 1/2 mv squared. And this is going to be the formula we're going to use to find the kinetic energy, because our variables that we have mass given in the question, and we have a speed. So given a mass and a speed, we have all the variables we need to solve for the kinetic energy. So let's fill in these values. The mass is 6.0 kilograms, and the speed was 7.6 meters per second. Right? And then obviously from the question, EK, or kinetic energy, is our unknown. That's the value we're trying to find. So let's plug in these variables. So we're going to plug in our variables into our equation. So again, our equation, EK is equal to 1/2 mv squared. EK is our unknown. 1/2 m is 6.0 kilograms. And then 7.6 meters per second is our velocity, and that's going to be squared. So now let's just put these numbers into our calculator. So this EK is equal to, I'm gonna do this separately and this separately in this step. So 3.0 kilograms multiplied by the purple one. This is going to be 57.76. The units meters squared per second squared. And again, just multiplying these together. These two together, we get 173.28 kilogram meters squared per second squared. And this is a unit joules, a unit of energy. So that's good. And when we're writing out our final answer, I'm going to round this off. I'm going to round it just to 3 significant digits, take off the decimals. So it's going to be 173 joules. So that is the kinetic energy of the sledgehammer. So I'm going to write here in blue that EK is equal to 173 joules. Okay, now let's move on to the next one, where it asks us, what was the average force exerted on the fence by the sledgehammer? So the formula we're going to use in this step is that work is equal to force times distance. And let me explain that. So work is a unit of force applied by and moving in a certain distance. So the fact that we applied a force and drove the fence post 14 centimeters into the ground, that tells us that work was done. Work is the transfer of kinetic energy. Not necessarily kinetic. In this case, it'll be the transfer of kinetic energy, but in general, it's just the transfer of energy that results in motion. So work is a transfer of energy that results in motion. And we had a transfer of energy that resulted in motion, 14 centimeters. So since this is the transfer of energy, we know this value. We know how much energy was transferred from the sledgehammer to the fence post. And that's this value here. So this means that when the sledgehammer was just about to hit the fence post, it had a kinetic energy stored up in it of 173 joules, and then it transferred it all into the fence post, causing it to go down. So the work here is going to be our energy, our kinetic energy in the sledgehammer. The forces are unknown, and the distance is our 14 centimeters. So let me do this here. Distance is 14 centimeters, and we want to all work in SI units. So converting that to meters is going to be 0.14 meters. And I just moved the decimal back 2 spots to go from centimeters to meters. Okay, so now let's plug in all our known values into this equation. So work is equal to force times distance. The work, remember, is our kinetic energy, so I'm actually going to use this value here with the decimals because it'll be more accurate. So 173.28, and the units, I'm going to write joules, kilogram, meters squared per second squared. That is equal to, remember, our force is our unknown, and then our distance, well, distance is 0.14 meters. 0.14 meters. So now all we have to do is isolate F. So let's bring this to the other side of the equation, and since it's a multiplication here, it's going to be a division on the other side. So I'm going to write that out. Kilogram meters squared per second squared divided, we're going to divide that, so underneath 0.14 meters is equal to F. And I was writing it out like this so that we can see that the meters cancel out and we get rid of this squared on the top for the meters. So we're left with the units kilogram meters per second squared, which is a Newton. So these units are Newton. So let's plug this into our calculator, and we will get a force of 1,237 and a bunch of decimals. The units is newtons. That is equal to our force. So for writing out our final answer, I want to clean this up a little bit. So force is equal to, and in the question we're just given 2 significant digits and all these values. So in our final answer, I'm going to round this to 2 significant digits, and this decimal is going to come 1, 2, 3 spots backwards. So 1.2 times 10 to the 3 newtons. So we know that the force applied is 1.2 times 10 to the 3 newtons. That is the final answer.